Okay, so welcome everyone to the next Probe Software webinar. It's the fourth one, and today we will talk about both PictureSnapApp and high sensitivity, high accuracy trace element analysis. So two very different topics, but I hope both equally useful to the people that had the time to dial in. I hope that other people will also maybe find it useful when we later load up these presentations to the YouTube channel of Probe Software. So these presentations are supposed to serve as a little introduction, a little tutorial, giving a little bit of background to what the various tools and functionalities in Probe for EPMA, but also PictureSnapApp about. I traded a little bit of time with John. So the first presentation, my presentation will be 30 minutes, although now we started late, and followed by a break. And then we have, again, John talking about trace element analysis in general, but also how it's being done in Probe for EPMA afterwards. Okay, so my part of the talk is about talking about PictureSnap and PictureSnapApp. And so these are tools that are for, as it says in the title, sample navigation and documentation. And I couldn't think how to do my day-to-day workflows in the lab without them. And they're probably one of the things that, while a lot of like the nitty-gritty details of the advanced analysis remain kind of a black box to users, this navigation and documentation is the first thing that they really appreciate, specifically if they've been using microprobe analysis or other technical analysis for a longer time, because it has really improved compared to how I did it when I was a PhD student. Okay, so PictureSnap and PictureSnapApp share a couple of features, but also are distinctive in what they're doing. And so first, I want to just compare and contrast a little bit. So anyone who's been using PictureSnap, has been using Probe for EPMA, is hopefully already using PictureSnap, although I discovered some labs are not quite utilizing it as they should be, because again, it's awesome. PictureSnap is part of the software, so you start it out of Probe for EPMA, and then you can use it for sample navigation, documentation, annotation, and you can calibrate any bitmap or JPEG images. In contrast, PictureSnapApp was then developed as a standalone app because people like PictureSnap so much that they were like, well, that would be great if I could have it on the SEM or some other non-probe analytical instrument. But I will also show you that I actually have them both, and I use them both all the time because together they really sing. Similar to PictureSnap, PictureSnapApp also has the basic sample navigation, documentation, and annotation, and calibrate and JPEG image functionalities, but then there are a couple of differences between them. And part of it is due to the fact that one is a standalone one and the other one is directly tied to whatever project you have open in Probe for EPMA. So in PictureSnap, you can display your either already digitized or acquired analysis location points, and have them labeled so that it corresponds to the data output. So that is incredibly helpful and something I do all the time. I can also display the field of view of acquired images. And that is incredibly useful in the workflow. I can also digitize positions for analysis on an image in it. So while I can do that in PFE on the acquired backscatter images, sometimes you might have a thin section scan, or it's something outside. It's a feature that's larger than the field of view of an backscatter or a secondary image can do. So then digitizing on whatever calibrated image I have is very useful. And I can also import probe image and grid files. And so because it's tied to probe for EPMA, it works for Joule microprobes and Kamika microprobes. Then in contrast to it, PictureSnapApp offers much more custom point and field of view annotation options. It also has a fantastic image locator tool that I will show you. You can also import and export the annotations, and then you can transform stage coordinates. And so it supports, you can control other SEM, TEM microprobes by JOL or Kamika, but also FEI with it. So you can do integrated navigation. But then in addition, it also has a demo mode and a text, even more specifically, text annotation mode. And that you can then use on something like a laser ablation ICP-MS or the SIMS or something. And while you cannot drive these instruments with it, like move the stage, it can be really helpful to find analysis locations, or after you've done these analyses, it helps you to then continue your work on the microprobe or SEM, or vice versa. And that's what the transform stage coordinates are for, because oftentimes other instruments have different stage coordinates and stage coordinate systems. Okay, a short insight how sample documentation work happens in my lab. I have a document camera. I really like this EPMA one, but you can use any other one. It's kind of cheapish. It's like $100. And depending how the lighting situation is in the lab, I combine it with one of these light box tents that people use to photograph merge or something. But it works as a nice diffuser and or reduce glare. At my old lab at Minnesota, this is how it looked like. I had the camera in the lightbox tent, and then I had like an additional eventually glare. That's just a piece of cardboard to reduce a little bit the glare. And I would put the sample holder in with the samples. I had a little bubble level so that it would be somewhat plain to the surface, and I would snap a picture. You can also have like this makeshift digitization for thin sections with polarizing foil that worked really nice. So you can like on the spot do a quick high resolution thin section scan just with a $20 light pad and some polarizing foil. So it was quite versatile. Now that I'm at the University of British Columbia, we actually got a JOL camera stand, but I didn't particularly like the camera that came with it. And I wanted, and it's integrated on the JOL side, but I wanted to have the flexibility to use PictureSnap. So we modified it so that I would just take the EPEVO camera. And so the advantage is really it gives you a very nice picture. It's all aligned and there is no worry about a camera tilt or something. And that makes the pictures very like reproducible. And I will show you how useful that is. then in the workflow later, having some kind of guide system for the holder and whatnot. Just straight up, the picture can take up to 4K images. I usually take a lower resolution image. And then a trick is I usually put a custom cut piece of cardboard below the thin sections, because that often improves the contrast a little bit, specifically if you have very whitish, like very translucent thin sections, minerals. So that's quite useful. Of course, you don't have to take the piece of cardboard out. And then with all this, you can calibrate these camera pictures, but also any thin section scans to be used for navigation, or to then add annotations onto it. And as I mentioned, it doesn't really matter what kind of image or map it is that you're using. So you can also use CL images, specifically if you don't have a CL on the probe or something. It can be very difficult sometimes to locate the specific zoning that you see in the CL. Again, just based on backscatter or secondary. So being able to navigate directly on the CL image can be really useful. We have kind of like a ChemScan MLA software that does mineral mode analysis. It's Broca Amex software. And so when I have that, and I can have that for the whole thin section, I can just use that and go straight to the grains that are shown as my desired target. Or you could also combine it with EBSD images, or again, whatever you want to use. I will do mostly tutorials then, but just to show you, specifically with PictureSnapApp, because it is a standalone software, you need to tell it what kind of stage you have and what the stage limits are as the first step when you install it. Not every time, just when you install it. Whereas PictureSnap, because it's part of PFE, it's already calibrated and whatnot. It already knows how to control the instrument. So yeah, you start out and there are all these different options that you can do. Today I will use the demonstration mode to show you things. Again, the text input is where you don't drive, where you're just on your laptop or something and you're not trying to drive something, but you want to annotate and maybe read out coordinates so that you can use them on a different type of instrument. And these are all otherwise the type of instruments and that it can control. And it doesn't list the IHP 200F, ISP 100s. You just use the A230, 8530 interface, but it definitely works. That's what I have, and so it does. So you set that all up. There are different types of, I mentioned stage coordinate system. Cartesian is what Kamika uses. Anti-Cartesian is what JL uses. And half Cartesian is when you have like a microscope doing a lot of the imaging. So laser ICP-MS, SIMS or something would be half Cartesian. And so if you're in text annotation mode, you have to make sure that it's set up to what you want to digitize, and then when you take it to a different instrument, you can just transform these coordinates so that they are working for a microprobe or wherever you took it, or vice versa. Okay, so then when you do the calibrations, there are different types of calibrations that you can do. If you have an image that is fresh, is uncalibrated, the simplest thing is you can do a 2-point calibration. So you just pick 2 points, and ideally along a diagonal, like kind of 45-degree angle. And you go and you pick the pixel coordinate on the image. You say, I'm here, and then you read in the stage coordinates. So you physically move to that point, you identify it, and then you say, read stage, and then you do the same thing for the second point. You pick the pixel on the image, and then you're physically at that location. You say read stage, and then you just say calibrate picture. So that's the easiest way, but maybe you want to rather do a 3-point calibration, because that also takes care of rotation and whatnot, and that just works the same way. You can also go from a simple 3-point, a 2-point location to a second, from a 2-point to a 3-point one. And the trick then is just that you do your 2-point calibration, and then you move first to the 3rd point, and then you switch over to 3-point, and then you just say pick pixel coordinate and read stage and recalibrate the picture. So that's when you have a maiden one. But I can tell you that actually there's a nice little trick that I want to show you that is much easier to do. So one thing is, again, and it makes use of the fact that if you have like a well set up camera system, it can be very simple and very quickly done, and no one wants to waste time in the morning. Okay, so let's say I have an image, and so that image would be not calibrated, and so I would have to manually go to all these positions and find them and whatnot. So that would be a little bit annoying if I have to do that, or at least it's annoying to me, because there's a faster way. And the faster way is just, so now when I go to my actual image files, so that was the image that I opened. If I have a similar, an older image from a different run, but with the same type of holder, I can just take that file, the ACQ file, because that contains the calibration information, and I just copy and paste it in the same folder, and then I go and I take the image file name and just paste it on this copy of the ACQ file. And now when I reopen my image, it is calibrated. And it might not be perfectly calibrated, but it's pretty well calibrated. The biggest differences are moving the sample in and out, and the way I crop the image. So being somewhat consistent there can really make things much, much faster. So then I can just recalibrate my 3 points, but I can actually double click on the image, and I can move there, and I can say, oh, I'm here, pick pixel coordinate, and then read stage, and just revisit that. And just as another note, one of the reasons why I tape extensively my thin sections into the holder is because I really love using carbon tape. So a big part of its usage is just that carbon tape is very easy to see in your camera picture. It's very easy to see in your secondary or backscatter image. There's no question which one is which. Like, you know that you're on the corner of carbon tape, versus if you use some kind of mineral phase or something in the image, then there's always like, was it this spinel or was it the other spinel or something? You can get distracted. So that is a very, very useful trick to me that John Purnell showed me. So now you have your calibrated image file. And now you might have really nice thin section scans that you also want to calibrate. And so there it's a little bit more difficult to copy a file. And actually, I should have kept that open because, okay, So for that, I hope that works. I made a little video. I hope everyone can see it. And okay, so what you see here is I try to do a picture-in-picture kind of thing. In the upper left, you will see the SEM center image, so the backscatter secondary image. Here is the OM monitor from my JOL computer side, and here is my PFE side. And so I have my calibrated image of from my camera, and now I want to calibrate my thin section scan. And so one of the amazing things to me when you have both PictureSnapApp and PictureSnap on your computer is that both run happily alongside each other. So you can have both open at the same time, and you can use both to navigate or to track the other one. And that makes calibrating any other images, specifically if they are smaller, if they are shorter, really a breeze. And this is what I'm trying to show here now. Okay, so I want to take one of these beautiful thin section scans, cross-polarized, plane polarized. And so for that, I first open my calibrated document camera image. And so I have that. There's an overview image that I can close because I acquire the document camera image at a resolution that doesn't need it. And then I go to the probe software. I have a project open, and now I open up my thin section scan that I want to calibrate, and it's a very high resolution. So if I want to see the entire thin section, I can open this full image picture viewer. But I like having the high resolution of the thin section scan because that will give me also very clear positioning for my annotations later. So now I want to calibrate my a 3-point calibration of my thin section scan. So I opened that dialog, and now I can use my document camera image that may have a more coarse calibration just by the low resolution, and you can only click so exactly on a piece of carbon tape corner. And but now I have that to go to a part of the thin section. I know exactly where I am, but also when I move around, it keeps tracking what I'm doing. So now I can use that and find a good position. I focus my Z because even if the thin section is a little bit inclined, everyone is by the lowest degree. By having a 3-point calibration, it usually does an excellent job of keeping my my Z focus during navigation kind of almost perfectly on point. It's also really great for remote operations to have that thin section scan and that, because I barely have to touch up the Z. And so again, now I do the second point. I go at, and I want to have points that are as far away from each other as possible. And so I find my second point, I go, I adjust the Z, I position it as good as I can, and I pick my pixel coordinate for the second point where I know I am, and then read the stage coordinate, and then I find a good spot on the thin section scan again that I think I can find easily and move there. And so third one, again, the document camera picture is difficult to see, and that's where the a little bit for these faces, but in the thin section scan, it's very easy. And so I go to the next, my last point, again, focus and set that up. And so select pixel coordinate, third one, and boom, it's calibrated. If everything worked out, it says okay. If not, it gives me an error message. You see that the square is my field of view. It's slightly tilted because the thin section scan was slightly tilted, or the way I put the one is there. And so now I can use the overview image, and when I move elsewhere, it automatically moves the area of my high resolution thin section scan to that. So I don't have to go and search for that part. When I change the magnification, it adjusts this blue square. So that's the magnification, the field of view there. And at the same time, I still have the document camera image to tell me also like what the bigger scheme of things. So if I want to switch over to the next sample. So now I also have a cross-polarized light version of that scan. So I use my trick. I just copy the calibration of the other one, because they should be very, very similar. And I just paste the name of the cross-polarized one over the copy of the ACQ one. And now I can just open that cross-polarized image, and again, I can just touch up the calibration. If you have, when you digitize your images, if it's very rigid and you can like just digitize it in different, like if you have something like the Zeiss microscope camera that does it all automatically, then probably the calibration would be immediately perfect. But in this case, again, where it was like done by hand and cropped and whatnot, we might be ever so slightly off. But it's good enough that I can just move to a different area, and I'm within the field of view essentially of where the actual point is. And so boom, I have my other calibration, my next file calibrated. And so that's also then the easy way to then make use of CL images. Like I go down in magnification essentially of the images and have like easy control. And I can only do that by having both softwares running on the computer, so that I can have essentially two different files open at the same time. Okay, good. So that was how the calibration work. And of course, it always takes longer than I think, but now I want to kind of show you for a moment what kind of annotations we get. So I have PictureSnapApp. There are different, this is in demo mode. And there are different things that I can do with it. So one is that is really great is I can annotate current positions. So with Shift P under MISC, I can put in something and say, this was my EDS point. So that's what I use it a lot at the beginning, to create documentation for any kind of EDS work that I've done. Or if I took pictures with some other kind of, so I can zoom in and out, and then I can also say this, I took an EDS map or something in this area, and I have exactly the dimensions of it. So I can go around and just annotate points and field of views. And I can also go then later into these lists under window, show point annotation list. I can edit them if I want to change something, but I can also move back to that stage position. So it's very easy for me to essentially say waypoints, because oftentimes people first go through and do EDS and then later they set the points. So, and then it's like, damn it, I should have sort of made an annotation where that actually was. That was interesting. And again, there's also export import options in here. Then the other thing that is great that you can do is, let's open my thin section scan, and I open a smaller version of it just so that it's easier to see. than this like very large one that I showed before. And so there's the image locator tool. And so what I can do is I can load in with add calibrated images, backscatter images that I acquired throughout like doing the analysis. And so with that, if I highlight them, I can all have them shown in their correct location. There's no additional calibration needed. I can have it without displaying the image name and the image border. Let's move a little bit pseudo away. So boom, I know exactly where I took my images, and maybe I want to show something that's better seen in the backscatter. And then I can just save the entire thing as a bitmap. Or even nicer, maybe I took some maps, and so I want to go in and have an instead of the backscatter images, I want to have my maps that I acquired shown. And these are the magnesium maps of the garnets there. And so by highlighting all of them, again, they're perfectly in place, correct rotation, whatnot. And I have that. And then later I can even then superimpose analytical locations where I did spot analysis over that. So that is a fantastic tool to create any kind of annotations and whatnot with that. Again, there are transform options, and then yeah, when you're done, you say save as bitmap, burn in annotations, and save to bitmap. Sometimes I get an error message that it can't open clipboard or something. That's a Windows problem. And just as a tip, I found that when I use then copy to clipboard and then use again save as bitmap, then it works. So that seems to do something with Windows to giving it access to the clipboard again. And then lastly, I just want to show PictureSnap, what you can do in there, because I'm already running over time. And so there I open PictureSnap. You can always run it in offline processing mode, but I will show it to you in simulation mode. So I interface to the microprobe hardware because that gives me another option that is really useful. So I open my MDB file. My MDB file has the 3 images that I just showed. I can open display PictureSnap from the run menu. There it is. I grab my overview image that I just had. And so, or I could open my thin section image. And now I want to display all the acquired image points that I had. Now, an important thing is that actually for that, it wants to have the analyze window open. Otherwise, you get a little error message that it can't access them. And then I say display acquired unknown samples on PictureSnap. And I actually have that were 2 runs. So I say skip disabled points to only get the 2 ones. And I need to say, oops, not cancel, pause. Yep, then it does not the refresh. And now I have my points there. And if I want to have them with the annotations that you also see in the Excel spreadsheet, they're shown here. They're short line labels. So these are just the line numbers. I can have also the long line labels. So then it would show the unknown number. On these overview images, this gets very cramped, but on a high resolution thin section scan, it's really, really useful. So let's take those off for the moment. And then in addition, I can also in here actually say display, under display acquired image field of use. And now it shows me image 1, image 2, image 3. And that is also super helpful if I want to make sure I have like all the images of all my locations seen. So there's that. Another useful thing, like let's say you're earlier in your process, you haven't acquired anything yet. You can also, let's take that off. I can also say display digitized unknown position samples. And again, it wants to have the automate window open so that it can access that. So display digitized. And here are all my digitized positions. So that is also super useful if I try to like cover some kind of grid or want to make sure that I got everything. So even during the before I analyzed anything, I can already use that to track, do I have all the images? Do I have like all the locations that I want? And again, we can just copy that, save that as its own bitmap file. And then I also mentioned you can like do in PictureSnap, use a right mouse click to digitize positions. So the way that would work is you make a new unknown. So that's the last one that's open. And then I go in, wait, let's bring that to the side so that you see what's going on, hopefully. And then I say use right mouse click. And so now I can go in and add additional points, or could do that again on a thin section scan or something else, and then verify them later. Good. I think that was, for the time that I have, most of what I wanted to show you. I'm sure I forgot something, but I will stop sharing, and I think there might be some questions. And you can also please put questions in the Q&A, and you can also, during the next presentation, keep asking questions if something comes up.
Oh, thank you, Annette. That was fantastic. I have to say, you have extended the capabilities of PictureSnap and PictureSnapApp beyond what I have ever used.
I use it all the time. Oh, and I forgot to mention one easy trick. If you need, for whatever reason, to calibrate something fresh, but it's very difficult to find, I do first a shitty 3-point calibration where all 3 points are within the field of view, because that, within my field of view, I probably know pretty well what is what. And then I calibrate that, and then I go to the extreme outer ends. And it will not be perfect, but at least I know roughly where I am, and then I update, and then I perfect the calibration.
Yeah, I just watching you, I already made a note that I might add a feature where you can just say add a calibration from another ACQ file or another
You have
project.
that actually. I
Oh,
just didn't quite yeah, in PictureSnap app you can load in an ACQ file as well.
no, I meant from an image that's not calibrated. Instead of
Okay.
yeah, instead of
Yeah,
editing and
yeah.
pasting in, yeah.
Yeah, although I mean I like, yeah, I
I,
don't mind the editing. It's
no,
very,
it's great. I mean, it's
it's
fantastic.
pretty
But
fast. It's just, so that's the thing. It's like, it's great to have documentation, and sometimes I also get stuff sent from people and have to return it, like I do contract work for commercial. They don't come in to do all that, and they need to know where things are, and it just needs to be quick.
yeah,
Um,
no.
so it really takes me just a few minutes in the morning to get all these files calibrated. Okay, let's see. And otherwise we take a break.
Why don't we uh well, we can take a break now just so we don't keep going, and then you can answer the questions during the break or during my
Yes,
talk. Maybe that
yes,
would be a good way to go.
that
And
sounds good.